Hi, I'm David Ng, and welcome to the Purple Hats Conference, where today Anuj and I will be talking about building anomaly detection using ML and data science. I'm a director of product management at Salesforce, supporting data science and machine learning teams. My team focuses on building products that detects malicious threat activities and provides timely response to information security events across Salesforce. Previously, I was a privacy program manager at Meta, where I was leading the privacy reviews for Instagram's advertisement platform. I also held positions as a senior manager of application security at PwC, where we provided solutions and strategy for global clients.
Hello everyone, I'm Anuj. I'm a principal security engineer at Salesforce, supporting and leading cross functional teams and enterprise level security initiatives. My expertise within security is in detection and response, threat intelligence, security engineering. Prior to joining Salesforce, I worked for Amazon, Lending Club Corporation, and a few startups here in the Silicon Valley. I'm big on innovations and I've filed multiple patents within security and ensured that the work got published in a few journals. I'm also a panel judge and a review committee member for various security conferences.
So let's start with a high level primer about what's data science. Um, it's quite a popular term nowadays. Data science is a branch of AI which involves studying and analyzing large volumes of data using various tools and techniques. It is used to find, unseen patterns and draw meaningful insights from data. As you can imagine, in the world of security, some companies can have, petabytes, large gigabytes of data per day. A data scientist role would be preparing the data, finding meaningful insights, conducting exploration analyses, and also sometimes developing visualization tools to develop models that would help us in any business functional use case for cybersecurity. And today, we'll be speaking to you about a few possible techniques of applying ML and data science in cybersecurity.
Anomaly detection. Anomaly detection is one of the most common use cases of machine learning. As David mentioned earlier, it's one of the techniques that's used in within cybersecurity space. Finding and identifying outliers helps to prevent fraud, adversary attacks, and network intrusions that can compromise your company's infrastructure. In this presentation, we'll go through how anomaly detection works and what machine learning techniques we can use and what benefits anomaly detection in ML for cybersecurity.
Yeah, and as the news mentioned, anomaly detection is basically a outlier detection. It involves building and identifying differences, deviations from the norm of a data set. Say in a large data set, you see 99% of the data behaving a certain way, but then you find these outliers, and that's what most use cases would do to identify these outliers. And before we kind of dive deep into our use case today, I want to mention that anomaly detection is used in many other industries as well, such as financial fraud, medicine, law enforcement. But what Anuj and I are building at Salesforce here, we do it for the purpose of cybersecurity.
So let's go through the few use cases that we use anomaly detection in cybersecurity. One of the primary things that we use anomaly detection is to identify attacks against identity, and then also system or account abuse, network intrusion attacks, supply chain attacks, and insider threat attacks. How are these used? These primary use cases that we see on a day-to-day basis requires some sort of anomaly detection, because going through these attacks with a manual basis is hard, because on a regular basis there are hundreds if not thousands of logins that happens on a company infrastructure. And similarly, on a day-to-day basis, we see a lot of softwares and systems that are used and they configured on a corporate infrastructure level. Finding misconfigurations, finding attacks is a needle in a haystack situation. So anomaly detection would be very helpful in these use cases.
Now, want to also give another, introductory slide about, the data science methodology. We're going to dive into each of these components, and want to also say that, the example that we're using today is just a generalized example about how your company or your organization can, apply, data science and ML for anomaly detection. Just like any other security use case, what do you do, at first about how do you secure your crown jewels of a company, right? So before we think about what needs to be secured, we have to develop a threat model, right? There's various examples of threat modeling. We're not going to get into which one's better or not. You have to identify a threat model first, and then after that, then as I mentioned about the large amount of security logs, user logs, app logs that you get just being as a security organization. You have to identify the right data sources, and I'll say, this is probably the most difficult part before you begin, even before you begin, building features, developing models, because it's possible that you might have incomplete data. It's possible that you might not have every data source that you need for this specific threat model. So this is very important as well. After you have identified the data sources, you're going to be scoping out your use cases. You want to scope out the activity that you want to identify within these data sources. Then after that, we get into the development of feature engineering. Again, we'll dive into a little deeper later on the slides about what feature engineering is. And after that, it's going to be building a anomaly detection as a service. And after that, post processes with anomalies with known indicators of attacks, just for further review. Now, this is not a, step by step, step one to step two to step three. It's going to be like a cycle of like, building a model, building features, testing it out, doing it again and again until you're comfortable with the appropriate efficacies of that model. Being in security, I'm sure many of you have encountered, false positives, false negatives, like those type of things. So it's really important to approach building this detection system with the mindset of it's going to take a lot of like testing, but we found that to be very useful here at Salesforce. So looking forward to sharing our example here.
Thank you, David. Let's go through the first step of the process, which is threat modeling. So threat modeling, which is very initial part of the workflow. This is where data scientists, threat researchers, detection and response engineers, they come together and try to understand the application or the service that's part of this incident. And this is the process where they try to understand possible attack vectors, and this typically includes some few sub steps. One is they try to understand what the application architecture diagram that's part of this incident. This includes the various components that interact with this application, the things like load balancers, things like whether the application is publicly available. They'll go to the flow charts, and that would be the first step. And the second step would be looking at all the assumptions that can be checked off or challenged, which could be things like, okay, is the application having some sort of compensating controls, or is the application exposed, or does it have any challenges that we need to take care of. This is the second step that goes through the process. And the third step is uh, potentially looking at the threats that are part of this workflow. Like, for example, when we identify uh, the application and we know that it's publicly exposed, what sort of potential threats are going to surface. These potential threats that are going to be surfaced are the ones that we definitely need to identify in the further steps. But this is where we identify them. And the last but not the least is to go through the attack patterns that we researched about, and then where we can detect these things, and of course the validation of our assumptions and these attack patterns. And the what are the outcomes, you may ask, and the outcomes of the threat modeling exercise. For instance, we may know how the malware performs command and control, and with the adversary that's in question, like how is the adversary move laterally. Given we know the application workflow and application architecture, we'll be able to find those things as a part of this process. So from the threat modeling exercise, we have an example where we can go through a sunburst incident, and for example, we can go through the authentication activity. So finding anomalous activity within authentication logs isn't easy. So we have to first identify the patterns. So based on what we know now, there were things that were identified during sunburst incident, like for example, forged SAML tokens that were used to authenticate into applications, and also things like illegitimate registrations of the SAML trust relationships, anomalous authentication requests to existing applications, and adding credentials to existing applications. These things are patterns that we know now, and if we happen to find any anomalous activity uh, around these patterns, that would surface a potential threat that you may want to address. The second step of the process is identifying environments and data sources. This step of the process will help us identify all the data sources that we may need in the machine learning model that we are going to build. This also helps us prioritize which environments that the incident is impacting. For instance, with respect to solar winds incident, we know that the adversary could have compromised an identity provider and create a malicious SAML token to gain access. This leads us to look for data sources that could provide visibility related to all SAML token activity. This application or any other different applications, and as well as identity providers. And going to the same example, we know that during the Sunburst incident, there were command and control attacks. So you may want to look for network logs where you will identify command and control detections. And also similarly, there are DNS logs. You could look for DNS queries that were made to malicious command and control domains. And similarly, there are other data sources such as domain controller logs or AD logs, where you can find anomalous activity as well. So it's really important to go through the incident and identify like which data sources that we want to look at and surface those anomalies, because doing this manually could take months, if not years in some cases. Given if the data is large, going through the process of threat modeling and identifying data sources would probably decrease the time to investigate.
Implementing data science and machine learning is going to help accelerate these types of detections and also investigation as well. But before we kind of begin deploying these models out there, as I mentioned earlier, we have to scope out the use cases to detect adversarial activity. Now, just a few scenarios here. After identifying the data sources to the incident, we have to define the specific use case, that could detect possible adversary activity. The work items below, we divided up in three different scenarios. The first one, we might already have a pipeline that ingests the identified data source and also the ML model for detection. In such case, we would be essentially looking for the outputs from the past, from either existing models or previous data that we had. We might have to rerun these models and produce detections at a lower threshold. So maybe lowering that variable to flag more detections, because as I mentioned earlier, how comfortable you are with the efficacy rate of the model. It's important that we tune the model appropriately. Another scenario would be maybe we might have to ingest new data source and create a new instance of an existing model, with another data source. Let's say we are trying to detect data exfiltration. We can have data exfiltration in company A, train a model to detect whenever you have a file size of download of a specific user of, let's say, 1 gigabyte, flag that as a detection. That model works great for company A. Same thing can be applied to company B and C, but that threshold is going to be determined by the entire team to see what's the most appropriate use cases. So the third scenario would be The data source is new, and we don't have any existing model, which would be, this model it will take a long time to develop. But in this such scenario, the data science pipeline should be in such a way that we can generate features necessary using declarative framework, as well as able to run anomaly detections as a service. That's kind of what we want to get to, is to build a service where we have multiple models that can be applicable for different businesses or different data sources.
So let's look at feature engineering, which is part of the next step of the process. So for new data sources, the data scientist should be able to compose a feature extraction pipeline with minimal code. This step of the process is actually the first step of feedback process. This is where the initial set of results are provided to threat researchers and engineers, where they would look at the data and partner with the data scientists to come up with a list of attributes, which are called as features, and then they decide on the feature set, and all these features should essentially be extracted, or rather should be taken into account while developing the model further. In the Sunburst incident, if we suspect the adversary would have tweaked the expiration time of a SAML token, we should derive that feature specifically, so that we capture that and double down on that specific feature so that we would find those specific anomalies. And there are similar use cases where, if you know that there's a command and control attack, you might want to focus on IP addresses, because focusing on IP addresses and selecting IP address as a feature, and finding anomalies will help you find that one odd needle in a haystack connection. This is the time of the process where, if you identify the right features and apply your anomaly detection model, you would find a greater success.
Thanks, Anuj. In the next step in the data science methodology, as I mentioned earlier, the anomaly detection is a service. Based on incident that was at stake, as a product owner, we would like to create buckets of these anomaly detection services. So, as I mentioned earlier, data exfiltration as one bucket. That's one example. Other examples of different detection services would be maybe account takeover, insider threat, maybe account abuse. And then in the earlier slides, we talked about supply chain vulnerability. So all these can be separate, different buckets of detections that you want to build. If you're building if you're looking for outliers, if you're looking for anomalies, usually you would use a unsupervised machine learning technique for anomaly detection. So this is the capability of taking input of a data set and some parameters to produce anomalies. What's differentiating from this data set. The service could be composed of there's many different ML techniques that can be utilized within the machine learning and the data science toolbox. PCA is one of them. K-means clustering, n nearest neighbor, isolation forest, just to name a few. Whatever technique you apply, again, want to think of it from a standpoint of of building a product, right? As a business, you want to find a technique that would yield repeatable results no matter what the data input is. You want to have a product that's going to give expected output, so maintain high true positive rates, because if a model generates 100 detections, but 95 of them were false positives, then you're not really pushing the needle in terms of increasing your security posture for your company. So this is why it's important to think of building your anomaly detection as a service.
So let's go to the um, one of the final steps in the process, which is the post processing. Once we have the feedback loop established between the data scientists and security engineers, it's important to make sure that we not only have false positives but also false negatives. It's important to not have either of them, but in real world case, it's okay to have false positives but not false negatives. So in this post processing process, we actually go through a feedback loop and introduce all the necessary filters that require to ensure that we don't have false negatives and as well as false positives. So this could be an example of, let's say, your anomaly is finding too many authentication anomalies, and this is the point where you need to identify whether those are really anomalies. Now, should we allow list a certain IP address range because that's a trusted IP address range, or should we um, allow list a specific account that is known to automate certain logins? This is the step where we have to collaborate with the data scientists and the engineers who are very familiar with the adversary TTPs, and provide suggestions, based on the indicators of attack, and then identifying those false positives and as well as false negatives, like because there would be chances where the attacker could have changed their attack techniques, or the attacker may have skipped certain things that were considered originally part of our threat modeling. So this is the time to come together and address those things. If you have any updates that you want to make to the attack patterns, or do you want to make sure that you want to cover a new pattern, this is the time where we address those things and we ensure both false positives and false negatives are taken care of.
Yeah. So after we discussed about building the post processing and building our anomaly detection as a service, I'd like to go over one specific case study that was published a few years ago about credential stuffing. According to a research conducted by Google, between 2006 and 2017, about 1.9 billion usernames and passwords were exposed via data breaches. Traded in the black market forums, dark web. These online breach credentials are exploited by bad actors in various ways. Towards um, again, financial services account, any kind of important and impactful type authentication. So across the internet, Akamai detected approximately 3.2 billion malicious logins per month, and this is back in 2018. Now, it was reported that 8.3 billion malicious login attempts from bots just within the month of June. This is back in 2018. So let's try to understand more about what we can do about this egregious technique used by attackers, right? Basically, stealing your credentials, reusing it for their own malicious purposes. As the attackers find new techniques, so can other companies, right? And now I'll let Anuj speak much more about it.
Right. Thanks, David. As David explained, there are billions of malicious logins that happen across the internet. So, how do we detect these things? Many credential stuffing detection techniques, they rely on static rule-based systems, and databases that we know about, like such as Have I Been Pawned? And these methods are static and reactive in nature. Generally speaking, it's estimated that an average of 15 months goes by before a breach gets reported, giving attackers a plenty of time to play with the data. So we need to find some certain proactive methods to address such things with minimum latency. So, generally speaking, the detection and defense technology that we develop must provide detection for businesses with different traffic volumes and different user bases located all around the world. Um, because we need to be able to detect as soon as the attack is happening, and ensuring there is no compromise of data that happens after the attack, and as well as ensure there is no successful account takeover. Um, you know this is important because once the account um, is breached, and if the attacker gets into the account, and most likely that the information will be viewed by the attacker. So we should need to ensure that our latency is low. We need to be able to ensure that the attack, as soon as the attack happens, we take care of the account by resetting their password, or ensuring the attacker does not get to the data. um, so the detection algorithm that draws upon rigorous research on credential stuffing patterns needs to ensure that there is at least a three-step process. One, it needs to have a temporal time series anomaly detection technique, where we analyze the traffic, and as well as we ensure we fingerprint the traffic, and as well as we remediate once the anomaly is found. um, the important thing with the analysis of the traffic is we need to have velocity as an important constraint, because detecting brute force attacks essentially comes with a large amount of traffic, with a lot of velocity, and they initially tend to try to um, sorry they try to brute force username and passwords. And the second important thing as a part of traffic analysis is the cardinality, detecting credential stuffers enumerating through multiple credentials with similar fingerprints. So what does this mean? This means that though they may have a large number of account username and passwords, we can identify, or rather fingerprint, these endpoints that are sending these that are sending this traffic. So once we find both um, velocity and cardinality, we then have to ensure that we fingerprint these attack patterns, and ensure we also find these anomalies where if there are any successful logins, we also come and remediate those successful logins. This is one of the case study that was published by Salesforce, and it's publicly available on our engineering blog.
Sort of summarize a lot of the things that we discussed about. What we're building, we are making, data driven decisions for the business. We have to be methodical as we build out this process and workflow. Something as identifying the right data source, that's something we just can't say, give us all your logs when this incident happened, and trying to find that needle in a haystack, as Anush mentioned. Building a process workflow to turn data into actionable insights is key to important. We think that building these anomaly detection products will definitely help reduce the time to investigate. It's going to reduce manual investigation time from months to days. This is just the beginning. I feel like, applying machine learning, data science to cybersecurity is something that many organizations are still exploring, and we're very happy to have begun doing this over here at Salesforce. We look forward to hearing your questions and comments. Thank you.